Hello, this is AP Computer Science. My name is John Maxwell. Today's topic is Java arrays. And before us, we see some of the basics. For example, in line 6, 7, and 8, we have ways to declare arrays. In line 6, we declare an array called numbers, which has the potential of storing 5 elements. When it's declared, there is there are zeros in every index 0 through 4. And once again, as we find with strings, array indexing begins at 0 and continues until 1 less than the length. In line 7, we see the use of an initializer list to create an array of 4 elements. So the elements at the start are 1, 13, -5, and 4, occupying indices 0, 1, 2, and 3. Note again, the last index, 3, is 1 less than the length, 4. Now in line 8, we set numbers2 equal to numbers1 in a declaration statement. And we might think that we're copying over the elements of numbers1 into numbers2, and that may be that you think that, and it's true right after that assignment. However, really what that does is have the arrays both point to the same memory reference, and we're going to explore this in detail in this video. Line 9 includes a 2D array, which we will discuss in later episodes, but we declare an array called MATI for matrix, and it has 2 rows and 5 columns. So the first coordinate 2 refers to the number of rows, and the second value 5 refers to the number of columns. We'll say this at this time, that the upper left coordinate of MATI will be 0, 0, 0 row, 0 column. So again, 2D arrays follow the zero-based indexing structure. Let's go over a couple of rules or items that are important to know for the beginner about arrays. The first is, once declared, they're not resizable. Not easily. You can't say, oops, I missed on 5, I really needed 10 elements. You would have to declare a new array and copy all over the elements from the old array into the new array. And it's not easily resizable, it's doable, but the best advice is to choose a size that will accommodate the data that you need to store. The other thing is that it's treated as a reference variable, and we haven't talked much about that, except to say when we see the new keyword, it indicates that it would be a reference variable and not a primitive data type like int, double, char, etc. The other thing you need to know is it's strictly typed. It contains only one type of data. In this case, I've declared arrays that hold ints, but I couldn't put a double in that array because it's strictly typed and only accepts homogeneous data. So that's it about declare. We'll move to assignment, and here is a simple assignment statement using square brace notation. I set the value of numbers at index 0, the first element, to 15. And so the elements are 15, 0, 0, 0 until the end, because when it's been declared, the default value in each index is 0. But in line 16, we set the first index to 15. That's a direct assignment. You can also access the length of an array using the length property. Notice, different than strings, does not have parentheses after it. An array does not have a host of methods associated with it, so it's a unique thing. It is a reference type variable, but it doesn't have methods. Number's length minus 1 is equal to 17, and so we replace 4 with 17 in numbers 1. Recall, length minus 1 is the last index of an array. So here we print out what numbers 1 is to just verify that numbers 1 has been changed to 17. We'll print out numbers 1 and perhaps we'll be surprised at the output. And then we look at numbers 2 at the last index, and you can see that we've assigned numbers 2 to be a reference to numbers 1, and so we should expect 17. Okay, so we get 17 here. We get what is a memory address for numbers 1 when we print out on line 22. And when we print out numbers 2, because it's an alias of numbers 1, we also get 17. So by changing numbers 1, we also change numbers 2 because they both refer to the same object in memory. It's also interesting to consider when an array is passed as a parameter to a method, such as I do on line 15 to the method parameters. So let's follow along. On line 5 we create an array called nums, and on line 6 we create a string called mealong with an assignment of joke. In line 7 we create a Scooby-Doo object, which was introduced in our last video, Scooby-Doo, and the object name is dog. And in line 8 we create a double mint, cheeky humor here, equal 15.5. And then we send dog, nums, and mealong as well as mint into the parameters function on line 9. Scooby-Doo is the first. The actual parameter is dog. The formal parameter is x. The actual parameter for the array is nums. The formal parameter is n. Mealong becomes y, and mint becomes m. And then we attempt to change all objects. We set the first index of n equal to 12. It's been declared with an initial value of 5. We set y to Franklin. We feed Scooby-Doo dog a biscuit, and that will add 10 to the 15 that biscuit received when dog was created. And we set m to 12.7, which is different than 15.5. And so what I want to explain here is how parameters are passed in Java. So the answer is down at the bottom. All parameters are passed by value. String is a bit of an exception, and we'll explain that as it goes on. So let me run this and show what it is when we output using the arrays class to string nums, what it is when we output mealong and get the biscuits for Scooby-Doo and print out mint. Will those things change? We'll find out. Okay. So indeed we found the assignment for 12 did change nums, but string reverted back to joke. It did not accept the Franklin change. When we fed Scooby Doo dog 10 biscuits, the total with the 15 we originally gave him at creation, he now has 25 biscuits. And Mint, which was 15.5 and changed to 12.7, resumes its value at 15.5. And so here's the explanation. Scooby-Doo and the array are reference variables, and the value, all parameters are passed by value, is the memory address. So I'd like to refer to the memory address as kind of like the key to the house. If you have the memory address, you can open the house and do whatever you want in the house, including changing values of array positions and updating the biscuits that Scooby-Doo eats through the feed method. And it's like giving the key to the house and allowing whatever changes need to be. And generally, reference type variables, those that are created with the new keyword, are able to affect these changes in methods. The string is an exception. String in Python and string in Java, and it may escape the attention of some of beginner students, is an immutable object, immutable. So immutable means it is unable to be changed, and we can clearly see that although we attempt to change it to Franklin, it reverts back to joke. Finally, the value of Mint is passed to M. What is in Mint? 15.5. And although we try to change it to 12.7, and if we needed to perform a calculation within the parameters function, we could do so using the value of 12.7. When the locus of operation returns to the main method, Mint resumes its value at 15.5 because only the value got copied in, not the reference to the primitive data type in memory. Summary: reference parameters and primitive data type variables are all passed by value, but the difference is what is the value. The value for a reference parameter is its memory location, which is a key to open access of that memory object. For an immutable string, this is an exception. Doesn't work that way, even though string is an object type. And for primitive data types, only the value contained in the variable is transferred, not the memory address. So there's no open access to change. This is a very typical part 1 question. Particularly in string, they'll ask you, what are the values of these variables after the function has completed its operation? And they'll give you a couple choices, and you hopefully will get them right based on this discussion. Okay, the final part of our discussion here is the use of arrays with loops. And I have a couple of examples here that hopefully will clarify this topic. It's surely only an introductory topic because this is something we need to return to. Funny fact, did you know, at least in my opinion, I think arrays are really big topic for the AP exam. So if you're going to Q on anything, You might as well start queuing on arrays because there'll be a lot of questions about them. So let's start with line 6 where we use an initializer list to declare an array called nums. And then we create an array of strings on line 7 with a size of 2, storing in the 0 and the 1 indices. It's empty, and I guess it's important to note here that when you declare an array of objects, all the items in the array are initially set to null. And null is a word that is that this object has not been created, so it's considered null. We'll expand on null in the future. So on line 9 and 10, we have a traditional for loop. So I begins at 0, which incidentally is the first index in an array. And it goes to, but not including slogan.length. And it increases by 1 I++ after every loop iteration. So we simply have an input statement allowing us to fill the empty array of string using the next line method of the scanner class. So what I want to add here is a little discussion about the loop. All loops have a start condition, I equals 0, have a stop evaluation, I is less than slogan.length. As long as that's true, the loop will continue. And a change feature, I++. And the way they handle these is a bit different depending on the type of loop that you're working with. Okay, so let's go back a little bit. We know that nums is an array, and we find a typical algorithm, a summative algorithm, where we attempt to total up the elements of nums. So looking on line 18, it's going to return an int and take in an array. And this is how the array is posed as a parameter. So we set a local variable, one that will expire when the function ends its execution, total num, and we run through the traditional for loop, starting at 0 and going I++ until we reach nums.length. And slowly add each I, notice we use the square brace notation, to add to the total num, returning total num when the loop finishes execution. It's pretty much the same for average, only it returns a double and it takes the array in. In order to get an average, we have to have a total. I suppose I could call the total function in order to do that, but I want to introduce a for each loop, which is a different type than the traditional loop. It goes through nums, removing or taking each element and temporarily storing it in X, starting with the first index and ending with the last. And so we add X to the total. Notice we don't need to use square brace notation up here because X is a integer, so we simply add it to total and then we return the double using cast as total and divided by nums.length, and you get the average. One thing you need to know about the for loop is that you can't change any of the elements in the array using this approach. What happens is X is a temporary value. Takes the first element, puts it in X, adds it to the total, takes the second element, adds it, puts it in X, adds it to the total, and so on and so forth. So X is sort of a temporary variable that whose value gets replaced with each step in the for loop. So changing X is not really changing the value at that index. So beware. The for loop is great to iterate through an array, but it's not advised for operations like insertion and deletion of elements or changing elements or things like that. It's just simply a good tool, simpler to use, easier to write, for iterating through an array. And here we have max value, which returns the maximum value in the array. And here we're using a while loop. And the features are that like it has the start, the stop, and the change, but in different places. So we have I equal 1 or 0 here, and that's the starting point. And you can see 0 is the traditional starting point for an array because we're going to start at the first element. Then we're going to go while I is less than nums.length. So that's cool, right? We can stop when I becomes equal to nums.length. And down here we have I plus plus. And it's often forgotten by beginning students. If you don't have I plus plus, you have an endless loop, which in the past used to crash the computer, but now computers have gotten much better. So they don't crash, but you will not have a running program. The logic of this is that max is equal to integer.min value. Hey, if you set it to 0 and they're all negative values, 0 is going to be the max value. So that's an inappropriate assignment. If you set it to minus 10,000, who knows if there isn't a minus 15,000 or a minus 5,000 in there that would be the max value. So it's best to, when they go low, stay low. Okay, and the lowest can be the min value. And it's kind of interesting to highlight it. It's negative 2 billion. Okay, so, recall again that integers have an upper and a lower range. Computers cannot handle infinite numbers yet. Actually, our mind can handle it, so I don't think computers can. Well, this is a classic. It's an if statement inside of a loop. If nums I is greater than max, then max becomes nums I. I kind of call this a king of the hill or queen of the hill. You get up on the top of the hill or the raft out in the lake or however it is, and you push down all the lower values or lower numbers. As soon as you find one that is greater than max, which is at the start the minimum value ever, then you set max equal to that. So one king or queen replaces another in this algorithm. And it is very much a problem that you'll see in particularly the written part. It's not uncommon to have an array question ask you to iterate or loop through an array and find values that match a certain criteria using an if statement. So an if statement inside a loop is a classic algorithm that you're going to have to be able to write. So we've introduced 3 types of loops. There are more. They're backward counting loops and loops that start in the end and only go halfway, and loops that start in the beginning and only go full way. So let's just run this. Okay, it's asking for the slogans right here, next line. So I'm going to go put a famous slogan, remember the Alamo. There we go. And then I'll have Java's slogan, write once, run anywhere. So those are 2 slogans. it's prompt me for 2. So this one here prints out the memory address, right? We've talked and harped about like that an array is just a memory address. But there's this nifty class which I've imported up at the top called arrays. And the arrays to string allows for the output of this line. Remember the Alamo write once, run anywhere. So that's a good shortcut for being able to check the contents of an array. You might want to inspect the arrays API to see if there's other methods that might be useful for you. Then finally we output the total, 12, -5, and 4 is indeed 11. The average is 3.6665. That works. And the max value is 12. Accurate. And so these methods introduce a critical companion to an array, which is a loop. First, the traditional for loop, then the for each loop, used in specialized cases for iterating but not changing elements in an array. And then finally the while loop, which has all 3 components, start, stop, and change, in different places within its structure. So, my favorite is the traditional for loop. I don't know about you, but this has been Arrays in AP Computer Science. Thank you for listening.